In this introductory video, we will give an overview of basic terminology needed in the study of statistics. What is statistics? We present some working definitions for basic understanding of the foundational ideas. Statistics is the science of collecting, organizing, and interpreting data. Data is any type of information packaged in numerical form. Individuals are the objects described by a set of data. For most social science research, individuals refers to people, but individuals can be animals, plants, or inanimate objects. A variable is any characteristic of an individual and can take on different values for different individuals. Examples include height, weight, age, income, nationality, gender, eye color, etc. The distribution of a variable describes all values the variable takes and how often it takes these values. These descriptions generally take the form of tables, charts, or graphs. There are generally two types of variables. There are quantitative variables and qualitative variables. Because the words quantitative and qualitative are so similar, I prefer using the adjectives numerical and categorical for types of variables. A numerical variable is a variable that takes values for which arithmetic operations make sense. A continuous numerical variable takes values whose differences can be arbitrarily small, variables like height, weight, or rainfall amount. A discrete numerical variable takes values that change by some minimum increment, like test scores, basketball game scores, or shoe size. In some ways, continuous and discrete variables are both treated like general numerical variables, but sometimes they have to be treated differently. A categorical variable is a variable that classifies an individual in one or more categories. Variables like nationality, gender, or ice cream flavor preference. Being able to identify a variable type is crucial to choosing the appropriate statistical method for analyzing a distribution. I like to think about the verbs involved in finding the variable values. Numerical variables have values we measure. For example, how much rain fell overnight. Categorical variables, on the other hand, have values we count. For example, how many Juneauites own a pair of extra tough boots? I've already mentioned a variety of examples. Some numerical variables are a person's height, weight, age, income, rainfall amount, test scores, scores of basketball games, etc. Some categorical variables are nationality, gender, hair color, brand name, activity, ice cream flavor, letter grade, opinion, status, etc. In general, there are two branches of statistics. These are descriptive statistics and inferential statistics. In descriptive statistics, the intention is to collect, organize, describe, and summarize data with charts, graphs, and/or numbers. In inferential statistics, the intention is to make decisions or draw conclusions based on data. Let's now consider some critically important definitions in inferential statistics. We will give basic working definitions. The population in a statistical study is the entire group of individuals about whom we want information. A sample is the part of the population from which we actually collect raw data. A parameter is a fixed value that describes the population. In practice, we don't know the actual value of this number. A statistic is a number that describes the sample. The value of a statistic varies from sample to sample. We often use a sample statistic to estimate an unknown population parameter. We also have specific notation for some commonly considered parameters in statistics. We use a capital letter N for the number of individuals in a population, and we use a lowercase n for the number of individuals in a sample. We use a lowercase Greek mu for a population mean, and we use x bar for a sample mean. Using Greek letters for the population parameters is pretty standard. We use a lowercase Greek sigma for a population standard deviation, and a lowercase s for a sample standard deviation. Notice that mu is the Greek m and sigma is the Greek s. The Greek letter for p is pi, but since pi already has a widely known fixed value, we often use lowercase p for a population proportion and use p hat for a sample proportion. However, sometimes even p means something else in statistics, and we have to substitute another symbol for the population proportion, as we will see in later videos.